Ukraine's Air Force just pulled off something unbelievable. For years, Russia has launched relentless missile and drone attacks, testing Ukraine's defenses. But this time, Ukraine had a new trick up its sleeve, one that caught everyone off guard. France's Mirage 2000 fighter jets, written off by some as outdated, just proved their worth in the most intense way possible. In a single night, they turned the tide against one of the largest Russian missile barrages in over a year. So how did these decades-old jets pull off what even cutting-edge systems struggle to do? And what does that mean for the future of air combat in Ukraine? Let's break it down. Just recently, the Mirages were deployed to be used in anti-air defense, particularly against Russian long-range missile and drone attacks. A report suggested that Ukrainian pilots who trained in France for months on how to fly the aircraft definitely show they've learned their lessons. The aircraft were pivotal in taking out cruise missiles, and President Volodymyr Zelensky applauded the pilots as well as France for providing the planes. But what made these planes so successful? How do they compare to contemporary aircraft that Ukraine has fielded so far, or that Russia is using? And what does using airplanes in this manner indicate for the future of the war? Stay tuned to find out. But let's first delve a bit deeper into the specifics of the attack and why the planes were seemingly so important they had to be singled out as a major contributing factor to Ukraine's defenses. In the early hours of March 7th, Russia launched yet another in the line of its numerous and potentially devastating long-range strikes. Battlefield reports from the attack suggested that Russia used as many as 67 missiles of various types and over 194 long-range drones to conduct the attack. These numbers make it one of the largest strikes in the past 12 months, at least by sheer numbers of long-range ordnance involved. Ukraine deployed its anti-air defense systems on the ground, including the Patriots, their own drone systems, electronic warfare, and traditional anti-air batteries. But the real action seemed to be happening in the air, where Ukraine called in its new stockpile of Dassault Mirage 2000 jets that were donated by France and arrived less than a month before. Ukraine also deployed a number of its F-16s to provide a vital supportive role. The aircraft were used to locate, intercept, and remove any larger threats posed to vital military and civilian compounds targeted in the strikes. According to a social media post by Zelensky shortly after the attack was seemingly repelled, the aircraft was successful in intercepting cruise missiles, which could have done considerable damage had they managed to strike their targets. So how did they do it? Well, there are only a few ways an airplane is actually useful against a high-speed cruise missile. Fighter jet interception of a cruise missile relies on a host of sophisticated technologies, each designed to enhance detection, tracking, and engagement effectiveness. The process begins with detection and tracking, where multiple systems need to work in unison. The ground-based radar emits radio waves that bounce off objects, allowing operators to detect and determine the missile's location even when it flies at low altitudes, though its low radar visibility due to a streamlined design means it often avoids detection. The fighter jets here constitute an airborne early warning system, being equipped with high-performance radar and communication systems of their own, which can cover vast areas and detect threats early, providing the fighter with critical situational awareness. Once the missile is detected, sensor fusion comes into play. This refers to the integration of data from these different sensor sources, creating a unified, accurate picture of the missile's position, speed, and trajectory. This is vital because no single sensor can capture all necessary information, and combining data enhances precision and allows the operation to move into the next stage. When it comes to engaging the missile, the fighter jet must be in an optimal position, a process that involves advanced maneuvering capabilities. Here, the jet's agility is key in positioning itself effectively within the missile's projected path. Luckily, both the F-16s and the Dassault Mirage 2000 were made to be as maneuverable and as fast as possible. This allows them to achieve speeds similar to that of the missile and allows them to approach it from different angles due to the aforementioned guidance systems. The primary weapon for interception is typically an air-to-air missile that employs active radar homing or infrared guidance. Active radar homing means that the missile carries its own radar system to seek out and lock onto the target, making it highly autonomous in tracking even if the target changes course. Infrared guidance, on the other hand, relies on the heat signature of the missile, allowing it to track targets based on their thermal emissions. These guidance systems are crucial because they ensure the missile remains locked on to the rapidly moving and often evasively maneuvering target. Typically, cruise missiles don't have built-in maneuvering protocols, instead following a predetermined trajectory that can be accounted for if you know the general target and the source of the missile. While this would generally make them easier to intercept on principle, missiles do have a trick up their sleeve. Most cruise missiles have relatively low thermal emissions and an aerodynamic design that also implements radar dispersal surfaces. Both of these systems make them more difficult to pick up by conventional anti-air missiles. That's where the next aspect of using fighter jets for missile interceptions comes in. Advanced computers on board can use data links to provide continuous updates between the launching fighter and the missile. The data stream syncs the missile's intended target and trajectory with the jet's own targeting system. This allows the pilot to make adjustments in real time to the missile's flight path based on the jet's more comprehensive sensor data. Another aspect of missile interception is dealing with electronic countermeasures (ECM) techniques used by hostile missiles to confuse or evade detection by emitting signals that can disrupt radar and guidance systems. The interception system must be robust enough to overcome these challenges through advanced signal processing and countermeasures, ensuring that the missile system remains on target despite any deliberate attempts to mislead its tracking systems. In cases where the engagement window is exceedingly short, the fighter might resort to a direct gun engagement. Although this method is far less effective against a high-speed, small target like a cruise missile due to the precision and rapid response required, it underscores the complexity and layered approach necessary in missile defense strategies. However, there's another aspect of electronic countermeasures that come into play when fighter jets are deployed against missiles and drones. In cases where drones can be programmed to seek out additional targets or are manually guided, the initial attack can be a ruse to lure out the aircraft. Then the attacker uses a second layer of missiles and drones to target the jets themselves. This turns the aircraft from supportive radar systems to active targets, making it necessary for the jets to carry its own suite of missile countermeasures. Somewhat unfortunately for Ukraine, electronic countermeasures could be particularly worrying for its prospects and is a part of the reason why the Mirage 2000s can become increasingly useful as the first line of defense against long-range strikes. You see, a big part of why Ukraine has been so insistent on receiving F-16 fighter jets as part of NATO donations was due to their advanced onboard radar and tracking systems. In particular, the contemporary versions of F-16s, those that were used by NATO countries and then subsequently retrofitted and donated to Ukraine, carry the AN/ALQ-131 electronic countermeasures pod. The AN/ALQ-131 is considered one of the most robust and future-proof designs in radar jamming and countermeasure capabilities. Developed to jam and confuse adversary radar systems, the AN/ALQ-131 works by emitting deceptive signals that interfere with the tracking and targeting capabilities of hostile sensors. Essentially, the 131 creates false results on the enemy's radar and other targeting systems, generating noise that the enemy must account for when deploying strikes. The system was considered a pivotal upgrade to the Ukrainian Air Forces when it first came alongside the F-16s. Previously, the Ukrainian aircraft were of Soviet design, using older third-generation and fourth-generation aircraft left over from the collapse of the Soviet Union. While the Ukrainian military did its best to keep the equipment in shape, these aircraft weren't compatible with Western anti-radar designs like the AN/ALQ-131. This meant that when the war in Ukraine started in 2022, the Air Force needed to take flight with pretty much zero reassurance that they could survive Russia's overwhelming long-range strikes and missiles. Before the procurement of the F-16, the Ukrainian Air Force wrote off 75 jets, at least according to a report by Forbes, with most of these losses due to their inability to repair the heavily damaged aircraft and salvage them for their spare parts instead. By contrast, the AN/ALQ-131 allowed Ukraine to create what was termed a local pocket of air superiority. By deploying the F-16s that carried these pods to the battlefield, the aircraft could jam Russian radar, sensors, and anti-air countermeasures, giving Ukraine a much-needed reprieve from Russia's counterfire. This helped stabilize or even minimize the potential losses of aircraft on active duty. As a result, Ukraine could then drastically improve its operational capacities when it comes to deploying aircraft as part of both offensive and defensive missions. However, the AN/ALQ operates at distinct frequencies, the same as those that the Russians used for their own radar and sensors. In turn, the Russians could change their sensor frequencies to attempt to bypass the jamming mechanism and minimize or even completely negate the effect the system had. In response, the Ukrainian jets would receive timely software updates prompted by the US and NATO intelligence services. These would keep pace with the constant signal switching. The constant back and forth between Russia's radar arrays and Ukraine's F-16 fighter jet countermeasures is what led to neither side being able to gain much progress over the course of 2024. As soon as Russia gained some ground by using a different type of radar or by changing the frequencies on which they operated the communication and targeting systems, the US, under the administration of former President Joe Biden, would track the change down and devise a countermeasure to be deployed. But this pace could only be kept up so long as the US provided vital intelligence support to Ukraine. And that support was briefly suspended by current President Donald Trump, though was reinstated shortly after. This was part of the Trump administration's stated attempt to end the war quickly. After the US began talks with Russia in Saudi Arabia in February, without Ukraine present, Trump decided to put more pressure on the arguably weaker side, that being Ukraine, by suspending military aid. This pause in military support was a precursor to the discontinuation of the sharing of US intelligence earlier in March, including updating F-16 software and radar systems to stay ahead of Russia's changes, but this too has now been reinstated. With that gone, the F-16s could have lost one of the main advantages they have. While the aircraft has performed superbly over the course of the war, they are still relatively old. First, the initial design for the F-16s came before 1980, and the aircraft are technically a full generation behind contemporary multi-role fighters like the F-35 and F-22. More importantly, Russia has some of the world's most advanced radar and targeting technology, despite its failure to utilize it properly in the war in Ukraine. Without the ALQ-131, the F-16 is much more vulnerable to Russian attacks. As such, they may no longer be a cornerstone of Ukraine's aerial defenses, and that's where the French Mirage 2000s come into play. Conceived around the same time as the F-16 and developed to keep pace with the rapidly progressing American aircraft, the French fighter jet uses a system in some way similar to the ANALQ-131. In the French Air Forces, the Mirage 2000 F5, one of the most recent upgrades to the aircraft, flies with a combination of a servile radar warning system, a Sabre jammer, and an Eclair chaff and flare dispenser. This electronic countermeasure suite was on the cutting edge of aerial warfare in the 1980s, but began to fall behind a generation later. However, the French Ministry of Defense understood the severity of the ongoing war in Ukraine and the ever-present danger that the Russian missiles and advanced radar systems could pose. As such, the French Ministry of Defense announced that it would retrofit its existing Mirage 2000s with brand new countermeasures before donating them to Ukraine. There are two possible upgrades that are most likely being used in this case: the mostly analog Integrated Countermeasures Suite Mark II or the fully digital Integrated Countermeasures Suite Mark III. Both designs are contemporaries to the ANALQ-131, boasting similar effectiveness in jamming enemy radar and targeting systems. Either would be an improvement of the 1980s tech that the Mirages were previously flying, but even more importantly, both designs are actively maintained and iterated upon by the French military and intelligence services. This makes them a potential complete replacement for the American system. Due to the radar jammers being bound to their respective craft, it's highly likely that Ukraine will slow down its use of F-16s in favor of the Mirage 2000s. There's another excellent route that Ukraine could take, and that's to alternate between the two designs or use them in conjunction with one another on different frequencies. The latter option is perhaps why the most recent attack mentioned Ukraine deploying both F-16s and Mirage 2000s. By leveraging both types of radars, the Ukrainian Air Force has a much higher probability of actually affecting Russian targeting systems and sensors. Even if the Russians manage to bypass one of the options, there's still another to go through. This increases the operational complexity for the Russian army and forces it to be much more adaptable to real-time changes. And by now we've seen how that has gone for Russia. The lack of adaptability and willingness to adopt more innovative strategies is partially the reason Russia has failed to enforce complete air superiority over Ukraine, and why the initial invasion of Kyiv in the first few months of the war ultimately failed. But how does the Mirage 2000 compare to the F-16 in fields other than its countermeasure suite? The F-16 Fighting Falcon and the Mirage 2000 are both single-engine, multi-role fighters, but they cater to different operational philosophies. The F-16 has evolved into a highly versatile aircraft with cutting-edge avionics, an AESA radar, such as the AN/APG-83 for the latest variants, and the ability to integrate modern weapon systems like the AIM-120 AMRAAM and precision-guided munitions. Its fly-by-wire controls, superior maneuverability, and high thrust-to-weight ratio give it strong dogfighting capabilities. The latest F-16-5, Block 70-72, also includes advanced electronic warfare systems, data confusion, and advanced data link capabilities, as well as improved cockpit ergonomics, making it one of the most technologically advanced fourth-generation fighters. The Mirage 2000 retains its delta-wing design of the predecessor, emphasizing high-speed performance and rapid climbing rates over stealth. While older variants have been phased out, the Mirage 2005 and Mirage 2009 remain relevant due to their upgraded avionics, RDY radar, capable of engaging multiple targets, and modern weapons capability, including the MICA infrared and radar-guided missiles. But unlike the F-16, the Mirage 2000 lacks thrust vectoring. However, it compensates with high-speed interception capabilities and a reduced radar cross-section. Its lack of an internal gun in some variants and older electronic warfare suites makes it slightly less adaptable in modern combat compared to the latest F-16 versions. This could have been solved by newer countermeasure systems, but their use in modern wars has been limited so far and remains to be proven. In terms of versatility, the F-16 has the edge, with superior sensors, radar, and electronic warfare capabilities. The F-16 also has the advantage of being able to integrate into modern NATO and Allied air forces due to its widespread use and constant upgrades. The Mirage 2000 is more specialized for high-speed interception and air superiority, with a smaller weapons load and fewer upgrade options. However, air superiority and interception are precisely what make the aircraft so potent for Ukraine. Over the past 3 years, Russia has tried and failed to enforce air superiority over Ukraine, thanks in part due to lacking sufficient expendable air forces to go through NATO-donated anti-air defenses. The first shipments of F-16s further increased Ukraine's defensive potential, and while their radar systems might no longer be updated as quickly, NATO still uses F-16s and its more advanced variants in many countries other than the US. This means that NATO's intelligence services, which directly support the Ukrainian military, can actively contribute to not one but 2 different aerial early warning and countermeasure systems. This improved versatility, combined with the Mirage 2000's focus on exerting aerial supremacy, could give Ukraine much-needed time to survive Russian strikes, and it's likely that time is what Ukraine needs the most. With US support in flux, there are a few different routes Ukraine and NATO could take. As soon as Trump made the announcement of suspending support, other NATO countries started scrambling for alternatives. By sheer numbers, the US made up between a third and a half of all economic and military donations to Ukraine year by year. This means that NATO countries would have to increase their output by 50 to 100% to match previous donation figures, which is not feasible for many members who are already failing to reach their own national defense quotas. More importantly, the US is vital in providing intelligence support and ammunition to Ukraine, both of which NATO hasn't developed nearly as much of over recent years. The questionable position of the US means that Ukraine will need to prove that it can defend itself by relying solely on the currently donated weapons and whatever plan comes from the rest of NATO. If this defense holds for the upcoming months, it could give Trump a sign to switch away from supporting Russia. After all, his stated desire to end the war quickly led him to side with Putin, as he considered that Russia had better odds of winning the war independently. That is supported by the deals Trump had tried to offer Zelensky, but the latter found unfavorable. If Ukraine proves that it can prolong the war, it would mean that neither Ukraine nor Russia will be willing to agree on a peace deal brokered by the US. In that case, considering that Russia has been the aggressor for over 3 years now, NATO could start considering more drastic support measures to end the war, such as deploying its own peacekeeping forces to enforce a ceasefire that benefits neither side geopolitically, but both of them militarily. But what do you think? Could France and the rest of Europe provide the same level of support the US previously did to Ukraine? Let us know in the comments, and thank you for watching.